Friends, welcome to the video demonstration of my project CISP, Cuda Image Signal Processing. This project is an attempt to execute image signal processing algorithms on GPU. So image signal processing algorithms mostly are parallel in nature. So they can be accelerated using parallel computing. So ISP pipeline is a software which converts bare domain images to RGB images. This project is a tunable ISP which user can change values of the change parameter of the pipeline to get the image they want. This demonstration doesn't contain any code review. It's just a guide on how to use the repository, how to access the source code, and how to experiment with the application. So here we have two Python source files, two Cuda source files, and an application. So this application is a compiled version of this app.py, and app2 is a much faster implementation of the same application. So this is the user interface. You can see that there is a path, and already a path is written in the text box. This is one of the sample images given with the repository. So you can just press enter and you'll get the bare image displayed here. So on the left you have so many controls. You can see there are so many toggle buttons, but the purpose of the toggle button is to switch and activate and deactivate various modules. So here are the name of the modules you have defective pixel correction, black level correction, line shading correction, AWB, CCM, CSE, and a few tone controls, then a few image filters, and then at last gamma correction. So you can toggle any of this on and off and run the kernel. It will still work. It's all independent. And then here is the tuning part. You can enter custom values here, all values you need. You can change the brightness, and when you press run kernel, it will run. And after tuning, after you got the image you want, you can press save image. You will get the output here. This is exactly how the application works. It's simple, it's intuitive, and now on to the code part. App.py have the application source code. You can change, make your minor corrections here. Then ISP contain the Cuda source code. You can see this. So this is important. It's the configuration structure. These are the parameters for the pipeline. It contains all the kernels that are executing the operations. You have the Python binding here. So what is the difference between ISP and ISP2? Why do I have two source files? So the problem is in ISP, you have this Cuda malloc. This is memory allocation on device. So whenever I am running the ISP, each time a Cuda malloc is happening and a Cuda free is happening. This is an expensive operation. There is too much overhead due to these two operations. So what ISP2 is doing is it doesn't have Cuda malloc or Cuda free. So how does it work? It's receiving memory pointers on device memory. Therefore, it doesn't have to create or destroy memory on every run. That will be done by the Python program. It will be creating memory once you press enter, and it will be passing that passing that variables again and again in a loop. And when you close the application, that memory is free. Therefore, the duplication of that process is removed. That is what ISP2 is doing. So that's it about the program, and I will demonstrate executing it in the console once so that you can see the latency of the code. Here you can see the latency of the code. It will be printed. So the code was executed in nearly 22 milliseconds. That is how fast the program is. And that is for an image with 3000 into 1000. Sorry, I don't remember the. Yeah, 3000 into 2000 image. That's it. That's it about the program. And I hope you like it.